Hi everyone, today we're doing 2 pages for 4.3. We're going to use similarity to find measurements. In other words, we're going to assume things are similar to solve. Awesome. Let's see. First method is scale factor. Lots of you like it. So let's see here. First step for all of these problems is to color code. You can find highlighters in our class bins. So that left leg, let's just call it red. That bottom leg, let's just call it blue. They could be any color as long as they're the same one. And that diagonal, let's just call it green. Awesome. And so here's what's neat about scale factors. I recommend, first step, let's call that highlight. Second step, I recommend going from small to big. That's my recommendation to you. Makes your life easy. So if I go from 4 to 12, because those are the only two numbers I know on both triangles, right? I know I must be multiplying by 3. How I might do that, more officially, just in case these become decimals later on, I take that ending number, which is 12, and divide it by my start number. But notice they're always the sides that are in the same position. And that's how I got 3. All right. So your book tries to get you to find a second scale factor, but let's just ignore that for now. Why do we care about this? Well, if I assume these are similar, then that means the whole triangle is 3 times as big. So if I go 8 to y, that y has to be 3 times bigger. So 8 times 3, that y has to be 24. Boom, done. But instead of coming up with a new scale factor, let's just use logic here. If A is 3 times bigger than B, that means B is 3 times smaller. In other words, we can divide by that same number. So 18 divided by 3 is 6. There we go. Done. So if you want to go forward, so let's say you found the scale factor. And if you want to go forward, you multiply. If you would like to go backwards, you divide. So you really need to put those arrows there because you will lose track of your work. Awesome. So the next one, ratio. This might be nice if you're getting a little overwhelmed because it always works. Let's see here. So just depending, first step is always highlight. Make sure we know things are in position. It also matters for ratio, just in a different way. I need 2 numbers that are actually numbers. So we have 12 over 18, right? I could have done 18 over 12, but let's just do 12 over 18. So that's pink over blue on my triangle A. So then on triangle B, I also need pink over blue, right? Which was 4 over x. So why does this help me? If you remember, we did cross multiplication practice a couple weeks ago. That's why we did it. All right. So anything inside the little circles gets multiplied. So 12 times x is just 12x. 8 times 4. Let's do another line. 8 times 4 is 72, which is equal to that 12x. And then here's the last step. A lot of people get confused. Anything next to that letter, that variable, is what we're dividing by. I'm going to show that's what we're dividing by. And so then 72 divided by 12 gets me 6. And there's no units, 6. If you notice, that's the same answer we got before. That means it does not matter what method you use. All right. So let's try it again with the other one. If we would like to find, 12 over y, right? They did 12 over y right there. That would be pink over green on triangle A. That means on triangle B, you also need pink, which is 4 over green, which is 8. All right? So let's see here. If we cross multiply 8 times 12, and then we'd cross multiply 4 times y, let's see what we get. 8 times 12, let's see, 96 is equal to 4y. Whatever number's next to that letter is what we're dividing by. So let's divide by 4. So 96 divided by 4 is 24. There you go. You got your answer. And it's the same one we got on the other problem. That's how we know. It does not matter what method we use. All right. Let's see. I'm just going to do 2 problems from here. Yeah, 2 problems from here. Let's do A and C. First step, let's highlight. Let's see, the shortest side, let's make that pink. That biggest side, let's make that green. And that middle side, let's make that blue. Again, colors don't really matter as long as they match. So, for this problem it says, use your method of choice. Scale factor or adjacent side ratios. When they say adjacent, they just mean, you know, those ratios you come up with, they have to have numbers next to each other. In a triangle or a rectangle, those are always going to be the same. All right. So I'm going to use scale factor because when you go from small to big, the numbers are nice. Let's see. 12 divided by 6. Your scale factor is 2, right? That means that triangle is 2 times bigger. When you multiply that blue leg by 2, you're going to get 10 meters. There you go. X is 10 meters. You know what? I'm going to, instead of that multiplication symbol, I'm going to use a dot so we don't get confused. All right. So that is scale factor. I'm going to use ratios down here because it might make life easier. Again, let's highlight. The long side is going to be blue. The short side, let's make that pink. There we go. All right. So we only have 2 numbers here. We're going to do x over 27.5. So that means I got to do the long side, 18.75, over the short side, 12.5. Those are our ratios. So next step, let's just set those ratios equal to each other. This is the ratio method. Let's make that clear. This is a ratio method. Okay. And then we need to cross multiply. X times 12.5 is just 12.5x. 18.75 times 27.5. Let's use a calculator on that one. Feel free to answer before me if you've got it. Okay, I got 515,625. And then the last step, divide by what's right there. So 515 divided by 515.625 divided by 12.5. So let's see, divided by 12.5. That should be 41.25. And let's see the units, they're using meters. So that's what you got. All right. So that's just 2 problems. If you'd like, take a break or, you know, close your eyes, stretch a little bit this time. That was a little bit. I know I am. All right. Let's see. Let's go on to the next page. And again, if you've got whole numbers, like 2 and 4, this is why I recommend highlighting. As you highlight, you notice some patterns. I think I'll use scale factor here because when I look at the small to the big, my scale factor there is going to equal 2. Scale factor is 2. And so if I have to go into the reverse direction, that means I just need to divide by 2. So 5 divided by 2 should equal, let's see here, 2.5. So my A is equal to 2.5 centimeters. There you go. So just as a recap, you first find your scale factor and then use it. All right, the next one. Let's use ratio just to keep things going. I would like to find B, and then I could use either side. I don't really care. Let's do B over 2, just because it's a nice number. So that means when I highlight this, I would need to use the same 2 sides. Let's see here. I used the green side before, so that means I use the green side again. And then I used the blue side, so that means I use the blue side again. If you notice, I'm not even using the red side. Not needed. All right, so let's use cross multiplication now that we set up, because we're doing ratios. We've got 7b is equal to 2 times 10.5. I believe that's 21. And so if you divide by 7, your B should just be 3 centimeters. Nice and easy. Or I should say just a nice round number. All right, let's try again. Let's see, let's use scale factor just because we can. If we'd like to go from 10 to D, let's go from 3 to 5. That means where we end needs to be divided by where we start. So let's see, 5 divided by 3. Our scale factor, let's get a decimal to make life easy. 5 divided by 3, that's let's do 1.67. And so that means we got to multiply by 1.67 again to get D. All right. When you do that, you should get about, let's see, 10 times 1.67 is about 16.67 centimeters. That's your D. 16.67 centimeters. All right. And then this last one. I don't know if you saw. It says each pair of figures is similar. And I told you, let's just assume all of these are similar. In similar shapes, I said that all angles need to be, I hope you said equal. And when I say all angles, I mean angles in the same position. So if it's right there, then in the same exact position right there, my C needs to be 60 degrees. There you go. No math needed. It's an equilateral triangle, so you probably knew that these were all 60. But you could also do that for any of these other triangles. So for example, if I said this was 30, then let's see here. This is also 30. If I said this was 45, this is 45. If I said this is 35, then you could say this is 35. That one's the weirder one, right? Because we flipped these triangles to be in a different direction. So that's why you got to be careful. All right, I hope that made sense. Feel free to rewatch the video if it didn't. And you'll see me in the next video.